Rustamdjan Hakimov. Please, Rustam, the screen is yours.
Thanks a lot, Thomas. Great talk. I'm also having a lot of questions, but now I'm happy to be here. And today I'm going to present the paper, which is a joint work with Dorothea Krupper, who is in Berlin, and most of you know her, and also Sichi Pan, who is in Melbourne now. And it's about costly information acquisitions in college admission markets. So in this paper, we are motivated by the fact that we observe that many students and their parents spend a lot of, or at least considerable amount of time every year to actually form their preferences over colleges. And these activities include searching the websites, maybe going into details of the program by considering university rankings, and also studying the costs and conditions for living on campuses. Of course, all these activities are at odds with the fact that usually in matching literature, we assume the fact that people just know their preferences. And this might lead to the fact that most of the mechanisms we consider rely on rank order lists, which essentially assume that people can rank all the universities costlessly. And maybe the fact that if you take into account this cost of forming preferences, maybe this mechanism actually turned out to be not that effective. And broadly speaking, in this paper, we aim to study procedures to potentially include improve the welfare of students if we include into consideration this cost of information acquisitions to form preferences. Why would mechanism matter for this? Because ideally, we don't want to spend time searching and acquiring information about universities which are outside of so-called our budget set. And budget set is just universities which are within reach. So those who would actually accept us or realistically accept us if we apply there. And of course, mechanism determines which universities are within reach, and not only, and this depends on priorities or how universities rank students, but also about preferences of other students, especially the ones who are kind of better than we are. And in this paper, we start with the simplest question, concentrating on a setup which is the most simple. Essentially, it's a serial dictatorship environment where all students are ranked in the same way by universities. This is apparently relatively surprisingly realistic setup for centralized college admissions. For instance, it's used in Tunisia or Germany or Turkey. So what we do in this paper, we look at the admission procedures which help people to identify their choice sets and thus hoping to improve their welfare. And we consider three serial dictatorship mechanism, which I likely don't have to spend time introducing here. By DRSD, we will refer to the direct serial dictatorship mechanism. This is just a mechanism where people submit rank order lists unconstrained to the designer, and then designer one by one assigns the best possible university according to rank order list to students in order of their priority. Then we consider sequential serial dictatorship mechanism. This is a mechanism where students move one by one. Every time student observes the set of available seats or universities with available seats and just choose the one she wants to attend. And finally, we consider cutoff policy. So it's the use of direct serial dictatorship mechanism, but also when before submitting the list, students observe the minimum grades which were required last year to get admitted to this university. So hopefully it's also helped them to refine their budget sets. So I have to skip, of course, literature and briefly introduce the model. Model is quite a standard college admission, one-sided college admission model where we have students, colleges, universities or colleges, Cs with quotas, and there is some ranking of students by exam grades. So being R1, meaning that student has the highest score and moves first. So that's the important part is how we model these preferences. So apparently modeling information acquisition is relatively complicated, at least for us, because things become not trackable quite fast. So this choice is exactly, this choice is a trade-off between semi-realisticity and the fact that we can actually track it theoretically. So students have strict preferences over colleges. That's what we think. But which preferences they have, they don't know. They know that this preference ordering is randomly and independently drawn from all set of possible orderings, actually from uniform distribution. So students know that any of the ordering is equally likely. Importantly, and this is a very important particular model and assumption that we have, students know their cardinal utilities, which correspond to each rank in their ordinal preferences. So essentially, students know they would be super happy to go to the top choice, less happy to the second choice, and so on. They know how much is super happy is, but they don't know exactly which university is the top choice and which is the second choice, and so on. And the search technology then works as follows, that starting from uniform prior, when they know that every ordering is equally likely, students can pay some positive cost to compare universities and to learn something about their preferences. First, for the first case, they just can compare two universities and they learn relative ranking of this. So for instance, they know that one university is better than the other. For additional K, they can add third university to this incomplete ranking. So they will know a relative ranking of 3 universities and so on. If they pay M minus 1K, they know ordinal ranking of all universities because there are M universities. And of course, students can step at any step of this procedure. So they can go all the way or not even start search, depending on the incentives they face. Hopefully, this example clarifies the search technology. We have 3 universities, A, B, and C. Students know that they will get, or a particular student knows that he will get 9 for the top choice, 6 for the second choice, and 3 for the third choice. However, the prior is uniform. Each ranking of this ABC is equally likely, meaning there are 6 permutations, so 1/6 probability for each of the rankings. So expected utility of each college here is equal to 6. So imagine now students decide to invest in acquiring information about colleges, for instance, invest in K to find out which college is better, C or B, and learns that C is better than B. At this moment, all rankings where B was better than C is actually getting 0 probability, and update is such that you just redistribute the remaining probability among the other possible rankings. That's how update happens. Importantly, prior about unsearched university A, it remains the same. This is an important part of the model, which makes it trackable, actually. So searching in B tells me nothing about expected utility in A. So, but of course, we get the better update about expected utility in B and C. So B is the worst one is 4, C is the better one is 8. Finally, if a student wants to pay additional cost, she will learn that her ranking is ABC. So the first proposition, and it's important to note, is that at every step of the search, there is a threshold for the searched colleges such that it splits search universities into groups. Some universities which are better than unsearched ones, and the other universities are the worse than unsearched ones. So in a sense, unsearched universities are always somehow in the middle of the rankings. This is, for instance, when we learned that C is better than B, A was in the middle. In experiment, for instance, we will have 6 universities, and let's say E and B are the ones where there was no search. They're going to be exactly in the middle between the search ones. This is important to know because this is important for optimal strategy under direct serial dictatorship mechanism under incomplete knowledge, because under direct serial dictatorship, students supposed to submit, it's optimal for them to submit the rank order lists such that colleges have a decreasing order of expected utilities. Under sequential serial dictatorship mechanism, it's optimal strategy to always choose the university with its highest expected utility, which is actually simple. It's just a university which is ranked the best among the search ones. It's always the one which has the highest expected utility. So our main theoretical result based on this model is that every student is weakly better off under sequential serial dictatorship than under direct serial dictatorship if they behave optimally. This is kind of straightforward in the sense that in sequential serial dictatorship, you can acquire information before you move, and you essentially always observe your budget set precisely, because before you take a decision, you know which universities would accept you, so your information acquisition is always non-wasteful. So what about historical cutoffs, where people observe it before submitting list in serial dictatorship? Of course, they also can help you to narrow down the budget set. However, this information is a bit noisy because preferences might have fluctuations and exam scores in universities. So it's a noisy information, but still informative. And we have very weak result, but it's a corollary where we know that the welfare and the cutoff should be exactly in between direct serial dictatorship and sequential serial dictatorship. So in the worst case, where cutoffs are very noisy and people, of course, have equilibrium belief about their informativeness, cutoffs cannot do worse than direct serial dictatorship, right? Because people are rational. In the best case, where cutoffs are precisely the same as last year, right? So they're super informative. The people, so students receive exactly the same information and as in sequential serial dictatorship. Importantly, before I switch to experiments, under cutoffs, we cannot already have precise point predictions for optimal search just because provision of the cutoffs change the we cannot rely on uniform prior anymore. So that's furthest we could go in terms of predictions of cutoffs. That's why experiment is actually even more important.
Excuse me, Rustam.
Yes.
Can you repeat why sequential is better than direct? I'm not sure.
Yeah. So in the direct, to make us how would you search? You would have to have a form preference. You would have to form beliefs about realizations of the budget set. But imagine for simplicity, you are student number 2, and there is one student number 1. Let's say Alex, and there is one seat, and then you have to in your favorite college, you have to form beliefs that Alex takes what's the probability that Alex, this favorite college will be available to you or not, and depending on this probability of this college being in your set, you might have different incentives to search or not. Well,
so basically, the assumption that in sequential you start search after you observe the choice of the previous players.
Yes, that's super important, and we will discuss. So you search already knowing your budget set, and that's exactly what drives the difference. Yes.
That's a quick question. In comparing the sequential versus the direct, students are better because they are paying less search cost, or because they get better assignments, or both?
The answer is both, because because sometimes you wouldn't in direct. Sometimes you, for instance, wouldn't acquire additional information because expected utility is lower. And here, so effect can be on both dimensions. Actually, in equilibrium on both, they pay less and they get better matches. And I think is Konstantin.
Yes, sorry. So here I have a feeling that this information acquisition is too taxing on the students because everything is independent. So I cannot free ride on the others as compared to reality. Because, for example, kind of if I'm studying in high school and I'm preparing for going to college, then I know kind of my peers, I know that they're looking for the right place too. I know some of them who have close interests to mine. And then it's kind of a collective search, right? So basically when I talk to them, I free ride on their effort also. But there's no such thing here, right?
No such thing here. It's a good point. I mean, in a sense, I would ask, how big are the search costs? And I think there are markets where it's not that big, and sometimes there are markets where there are a lot. If you think, you go to the new city, you move to the new city, and you get a child, and you have to form preferences of elementary schools. Not many people to free ride. So it's a good question, and we have various parameters depending on how. We don't have this free riding mechanism, but you can remodel it. That in some markets the cost is very cheap, essentially, right? That would be a similar way of doing it.
Let us give Rustam his remaining 10 minutes.
Let's try to talk afterwards. But it's it's a very fair point.
Okay, so thanks.
In terms of correlated preferences, the only thing that we could address is tiered priors, right? So we cannot track correlated preferences because essentially in direct mechanisms, things become very complicated, at least for us. But what we could do is that if there is some kind of tiered structure, which is some people argue is realistic for particular markets, for instance, China college admissions, then we can say we can see that our results generalized, because essentially you just have to every tier is a separate market, and you just search in your kind of market, you locate yourself. So what we do, we test this thing in experiment for several reasons. First of all, because the cutoffs predictions are very weak, and we don't. It's kind of a theory-free test of institution, but also because we think that in sequential mechanism there are some behavioral benefits, because there is it's simpler to search. It seems like it's simpler both to search and to have submission strategies and sequential mechanisms. So what we do is run an artificial market with 12 students and 6 universities with 2 seats each. Students are ranked based on exams scores, which are between 1 and 100, which are drawn uniformly. And students actually know their rank on the exams. This is also important. And the cardinal utilities of students are such that for top choice, they get $40, for second choice, 34, and so on. And these are Australian dollars, because it was done in Melbourne. And we have in total 3 treatments. So these are exactly the treatments I talked through: direct serial dictatorship, sequential serial dictatorship, or cutoffs. And we have 4 types of environments, either 2 or 1 tier. 2 tiers environments are simpler because you have only 3 universities which you're interested in. If you're top students, you're interested in top tier. If you're a bottom student, you're interested in bottom tier, kind of. In 1 tier environment, there are 6 universities which can all be ranked better than other. And we have different costs, either high and low, and the scores are chosen such to have a variety of predictions from complete search to almost no search. In the cutoffs, design was such that for particular market subjects saw the average cutoff scores from the direct session, right? And they were informed that these are the cutoff scores are taken from the other students who didn't actually observe any cutoffs. So for the treatments we have between subject design and within subject design on environments. That's why we have different orders of environments. They didn't play any role. In total, people play 8 rounds, and we have 12 independent observations, so 12 independent groups per treatment. So these are the main results. If you aggregate everything, we see the average payoff. So this is a proxy for welfare of students. And we see that our ranking of the treatments from theory actually translates into environment. We have sequential mechanism with the highest welfare and direct mechanism with the lowest welfare, and cutoffs is in between. Here it's important that, of course, we don't reach predicted levels because people do strategic mistakes. But what also important that the benefits of cutoffs treatment relatively to direct treatment is only pronounced in the environments where the search costs are high. When the search costs are low, there is no difference. So if you look, it may be related to Juan's questions, if you look at the components of welfare, on the left side, we see the university payoffs, right? It's just payoffs from the match. We see that here sequential mechanism does better than both treatments using direct, and there is no difference between cutoffs and direct mechanism. And on the right side, we see the search cost. Here, the direct has the highest search cost, sequential intermediate search cost, and cutoff is the lowest. So the essentially benefits of cutoffs comes through not from the better match, but from lower average search costs. If you look at the search behavior, whether people are rational, of course, there are many ways of looking at it, but here we just look at the average deviation. We see that and here there is no cutoff because we don't have point predictions for it. In the low-cost environment, we observe slight under-search, which is very untypical. Typically, people observe over-search in the experiments. And this is just explained that most of the people are predicted to acquire full information. So it's not really hard. It's very hard to over-search. While in high-cost environment, we observe over-search. However, here we it masks the deviation because over-search of one subject can compensate under search of another subject. So if you look at the average absolute deviations, we have very clear picture that people do less strategic mistakes in both high and low cost environment under sequential mechanism than under direct mechanism. This is not surprising because on this direct mechanism, they have to form beliefs about the budget sets, while in sequential mechanism not. So in a sense, there is this behavioral benefits that it's just simpler to understand how to search optimally. As for cutoffs, we don't have point prediction how they have to search. That's why we just do regression and see whether they react to cutoffs. And we see that this is a probability of searching in a particular school, depending whether cutoff is higher than your score and not. And we see that people are less likely to search in schools who have higher cutoffs. This is rational because they are less likely to be in their budget set. And especially they rely more on cutoffs in the environments where the cost of information, cost of search is high. Finally, if you look at this optimality of strategies, we see absolute optimality of 99% almost of strategies is optimal under sequential serial dictatorship mechanism, and only 80 indirect serial dictatorship. So now we can say whether it's driven by obvious strategy proofness, Shangguli's argument, or is it driven by the fact that for the direct serial dictatorship, you need to understand that unsearched universities are placed in between the searched ones. And actually, this is true. So the most of the deviations come from difficulty in comparing expected utilities, because actually violations of knowledge are very low in direct mechanism, still less than in sequential, but biggest deviation comes from this difficulty in comparing expected utilities. So to conclude, we think both welfare is improved in both sequential mechanism, and if historical cutoffs are provided, we think that sequential mechanisms have additionally behavioral benefits because it's simpler both in search and submission strategy. But of course, one could ask how uniform are our tier uniform priors, and probably not very realistic, but of tiered may be more realistic. And the conjecture is that under realistic prior structures, maybe the benefits of sequential is actually higher, because the complexity comes from impossibility to track optimality of strategy in direct mechanism, because now it's even more complicated to form your beliefs about your budget set once you have the correlated preferences. The other question is how realistic is the serial dictatorship? And actually, of course, probably not realistic that every student one by one moves and also has time to acquire information. But for instance, but there are dynamic mechanisms where this preference, this stylized evidence of simple model can transmit. For instance, in Tunisia, there is they essentially run the sequential serial dictatorship only by groups. First, top 33% graders move, then middle 33% graders, and third. And every time there is information update about vacancies in each university. So maybe 3 is too small, but if you do it at 100, I don't see why it's not possible, given that dynamic mechanism for college admissions are already used and run for several months in France or Germany. Moreover, there are some other mechanisms, for instance, college proposing deferred acceptance, where people observe offers. And maybe this has to be proven, but the conjecture is that the benefits might be generalized. So that's it. Thank you. Am I on time?
Yes, you're on time. We have a question from Peter. Rustam, please stop sharing.
If Peter has a question, or is it just a hand from last time?
Yeah, sorry, I left actually my hand, but I would have some questions. So actually I had a student, a master student, she did some nice experiments along similar lines. Our setting was different, so we used cardinal preferences instead of uniform random, but they were generated according to some kind of stochastic process. So anyway, the one comment is, actually this student, she compared the French case, the college proposing DA. I mean, in France, as I know, they really implemented this iterative college proposing DA for university admission, and it seems that it's working fine, and perhaps this is the main driver of the success, that the students they can save a lot of cost, because they have to submit the applications without preferences at the beginning, and they only compare the offers if they are coming. So anyway, I think it's a very important topic, and yeah, I will send you an email about the details what my student could achieve. But in general, the question whether you think it would be also useful to study like two-stage processes, such as in the first stage you have, let's say, a written exam, you refine, the rankings, and based on that you have a second measurement, an oral exam, let's say. I think this is also a process that is used in many places, like in Hungarian secondary school admissions, and can help in the coordination. Anyway, so.
First, a very short answer, please.
Yeah, so thanks a lot, Vita. I mean, I'm looking forward to see the paper, and yes, we also motivated a lot by French admissions, and I think it's something which matters. But let's talk offline now. I don't want to take Jonathan's time. Thanks a lot.